Hi everyone, this is Dr. A. Poongodai, Assistant Professor in CSE Allied AI Department, MITS Madanapalle Institute of Technology and Science. Today I am going to talk about the insertion sort. These are all the things which we are going to cover in the presentation. Insertion sort, it's a simple sorting algorithm and it is easy to implement. This algorithm works iteratively by inserting the first element of the unsorted list in the correct position in the sorted portion of the list. This we continue until the entire list is sorted. It is used to sort the small list of elements. Let's take an example. So the number of elements in the list is 7, 4, 3, 28, 2, 13, 18 and 9. It's in the unsorted list. We go with the several passes. In the first pass, the first element is considered as the sorted. Remaining all the elements are the unsorted list. So in the insertion sort, every pass we have to consider the first element of the unsorted list and it has to be inserted into the sorted list. So the element 4 we consider it as sorted. So the first element of unsorted list is 3. It has to be inserted into the sorted list. So we do the comparison and we insert the element 3 accordingly. So after first pass, 3 and 4 are sorted and 28 2. So this is the unsorted list. So this is the sorted list. After first pass, 2 elements are sorted. Next, second pass. So the sorted list are 3 and 4. Unsorted list remaining 5 elements. The first element of unsorted list is 28. So it has to be inserted into the sorted list. So after first pass, the element 3, 4 are sorted now and remaining elements are unsorted. Now we are going for the third pass. So here the first element of unsorted list is 2 and it has to be inserted into the sorted array. So after the pass 3, you can see that 2, 3, 4, 28 are sorted and the last 3 elements are unsorted list. So we are going with fourth pass. 2, 3, 4, 28 sorted list. We have to insert the 13 into the sorted list, which is the first element of the unsorted list. So all the first 5 elements are sorted, remaining 2 elements are unsorted. Now the first element of unsorted list is 18. 18 has to be inserted into the sorted list. So like that we will go with several passes. So if there are now here, so we can see here fifth pass, then 5 elements are sorted, first 5 elements are sorted, the last element in the unsorted only one element we have in the unsorted list, it has to be inserted into the sorted list, which is pass 6. So all the elements are sorted here. So we can see here there are 7 elements. So number of passes required is 6. So there are n elements means n minus 1 pass required. So very easy to implement. We can from this we understood that the list is, let me just go through once again. The list is sorted into splitted into 2 part. sorted and unsorted. So in the pass one, the first element we are considering it as sorted, remaining all are unsorted. So after pass 1, you can see here 2 elements are sorted. After pass 2, 3 elements are sorted. After pass 3, 4 elements are sorted. So like that it goes. So for n element, number of passes required is n minus 1. So the algorithm for the insertion sort: start the process, read the number of elements, read all the elements of the array, repeat the following steps 5 and 6 for n minus 1 times. N minus 1 time means because the number of passes required is n minus 1. That's why we have to repeat the loop for n minus 1 times. Insert the first element into the sorted portion. The first element is nothing but the x, nothing but the first element of unsorted list. How we are going to insert into the sorted array? So insertion into the sorted array. That's we have to discuss now. We understood the number of passes required is n minus 1. Now how we are going to insert into the sorted array? That is what we are going to discuss now. So this 6.1. So let's take the from element 2 to 13. All the items are sorted. We are having 2 elements in the unsorted list, that is 3 and 9. We should insert 3 into the sorted list. So you have to start comparing from the right end of the sorted array. So here, from here we have to, this is the right end of the sorted array. No? From 23 we have to start and you have to move towards left by comparing. So here 23, we are starting from the first thing, that is the right end. 23 is greater than 3. So you just move the 23 to next position. We have to move 23 to next position and 3 will be x, will be in the variable x. Next, we can see here 23 is moved from here. Now we are moving 13 to this position. Just you have to move the element towards one side, right side. How long you have to move this is until the x becomes greater than the element in the sorted array. We can see here 3 is less than 8. So 8 we are moving to the next position. So 8 is moved. So already 13 and 23 are moved. 8 is moved. Next again 3 is less than 4. Next to comparison we can understand here 3 is less than 4. So we have to move the 4 also to the next position. So 4 also moved here. So this 8 is moved, 13 is moved and 23 is moved. Now since 3 is less than 4, we have to insert 3 into the sorted array. So these are all the steps we are going through. So 4 is moved to the right side. Now 3 is not less than, so we should stop this moving to the next position. We should stop this process and insert the element 3. So this is the place we moved 4 here, no? So this is the place where we have to insert the 3. Since 2 is not greater than 3, 3 is placed in this position. So here it is very simple here. Easy to, we can understand, it's very easy to do it. And it's not taking much memory space also. Just you are doing the insertion in that array itself. We are not having one more copy. Only we need that variable x. You have to take that first element of unsorted list and you have to insert. No, so only that is the extra memory we need to perform this insertion sort. So let's see the implementation. first we have to read the size of the array, then we are reading all the elements of the array, then the insertion sort function is called. So read function to read all the array elements, and display function to display all the sorted array. So after calling the insertion function, we are calling the display function to display the sorted list. Next, insertion sort. We will discuss how the insertion sort function is implemented. Since the number of passes required is n minus 1, so we start with I equal to 0 to I less than n minus 1. Since for implementation, instead of having 0 to n minus 1, I want to have it as 1 to n minus 1. Because the 0th element A of 0 is considered as sorted list. So we are starting from I is equal to 1. So x is equal to initially, so x is equal to A of 1. The first element A of 0 is sorted list. We are going to take the second element and you are going to do the insertion. We are so here x is equal to A of 1. So we will start from j is equal to, we compare the second element with the first element. In the second pass, x of 0 comma 1 is sorted. Sorry, A of 0 comma 1 is sorted list. Now we have to insert x in the A of 0 comma 1, 0 to 1, that is 0 to 1. This is pass 1. In pass 2, we have to, I will become, in next pass I becomes 2. So x is equal to A of 2. It has to be inserted into the sorted array. We can see that until x is greater than A of j, we do the movement. The jth element is going to the element at index number j is going to the index number j plus 1 position. Once x becomes not greater than A of j, then we are in the else, we are going into the break. So the for loop is break and x is inserted into A of j. So this is how it is done. So let's see the number of time complexity and the space complexity. So here, since we have n minus 1 pass, so the number of pass required is n minus 1. And in each pass, how many maximum number of comparisons we will have. Suppose in pass 1 means there will be only one comparison, that is the element at the position number 1 is compared with position number 0. So I is equal to 1 and j equal to 0 now that time. So only one comparison we have in pass 1. In pass 2, we have two elements in the sorted list. So two element in sorted list, no? So x has to be the maximum number of comparison that can be done is x will be compared with two elements because two elements are in the sorted list. Next, in pass 3, if you see, so you have the sorted list is from 0 to 2. So 3 elements are in the sorted list. Since 3 elements are there in the sorted list, the maximum number of comparisons, sometimes it will be inserted in the middle only. But maximum, when we are calculating time complexity, we have to see the maximum number of comparison. So that's why for n minus 1, the maximum number of comparison it will be n minus 1. So the time number of comparison required is, if you count all totally, it becomes n square. Hence the time complexity for insertion sort is big O of n square. So already we have in previous presentation also, that is when I selection sort, I just talked about this worst case complexity, best case, average case. And so this, what is worst case is the elements totally it is in reverse order, it is the worst case. Already almost sorted, just very few element has to be kept into the sorted list, and averages it is partially sorted. Insertion sort works very well in the for this partially sorted list. It works very well in the partially sorted list. So just have a we have a recap. We select the first element from the unsorted portion of the list and inserted into the sorted portion. So this process we are repeating until the entire list is sorted. So total number of passes required in insertion sort is n minus 1. Generally we use the insertion sort to sort the small list. It's very easy to understand and implement. It works quickly for almost sorted sequence. That is what I said. And it sorts the input list without any additional memory. We don't want any additional memory thing. Just we need a single memory location, that is X, to which has to be inserted into the sorted portion. So this alone we need only location for having the variable X. So that's why not that much additional memory is required to do the insertion sort. Thank you.